Alright, g'day Year 9. Welcome back to week 2 of our online learning from home. Today what we're going to talk about is proving that Pythagoras' theorem shows that a triangle contains a right angle, or it does not contain a right angle. Today the first thing that you guys will need to do is we've got some 10 quick questions there for you, so you need to have a go at those 10 quick questions without the use of your calculator. Be very careful when we are dividing and multiplying with negative numbers. Remember that a negative multiplied by a negative or a negative divided by a negative is always positive, and that when our signs are different, a positive times a negative or a negative divided by a positive, if those signs are different, our answer is always a negative. So I'll get you to pause the video here, go to the lesson notes, complete those 10 quick questions, and then we'll pick up the video back from there. Alright, Year 9, thanks for doing those 10 quick questions. So the bulk of today's lesson is proving that a triangle contains a right angle. So a Pythagorean triple or a Pythagorean triad are three numbers that satisfy a squared plus b squared equals c squared. Alright, so satisfy means they make it work. The most commonly known triple, the most famous one of them all, is 3, 4, 5. And let's test that, see if that works. We know that 5 is the biggest value out of those triple. So if it's the biggest value, it must be the hypotenuse if this contains a right angle. And 3 and 4, well, they're the two shorter sides. So what we have here is then, well, 3 squared plus 4 squared, right? A squared plus b squared. So 3 squared is 9, 4 squared is 16, and we know that 9 plus 16 is 25, right? Now over on the right there, we know that 5 squared, so 5 times 5, well, that's also 25. So you can see here that, those two equal each other. Because those two equal each other, they satisfy the Pythagoras' theorem. They satisfy a squared plus b squared equals c squared. And because that's the case, if we were to make a triangle that has a side 3, the other side 4, and that third side 5, that triangle must contain a right angle inside it there. So let's move on. Alright guys, so looking at these examples here, we've got 3 examples of some triples here that we're going to look at. In that first example there, where we've got 6, 8, 10, well, clearly 10 being the largest number, it must be our hypotenuse. So 10 squared, which will be our c squared, well, 10 squared is 100. And on your calculators you can get out, and we'll try adding 6 squared and 8 squared, and 6 squared, which is 36, and 8 squared, which is 64. Well, 36 plus 64 equals 100. So yes, that works. And because that works, we know that if there's a triangle with 6, 8, and 10, there must be a right angle in there some. Moving on to that next row, again, 13, it's the largest number, so if this just does have a right angle, or if it's got to make Pythagoras' work, 13 is going to be that hypotenuse, and 5 and 12, well, they're our shorter sides. So what we're going to end up here is, well, 5 squared plus 12 squared, punch that onto our calculator. 5 squared is 25, 12 squared is 144, 25 plus 144 is 169. And 169 is the same value as 13 squared, so yes, that one does satisfy Pythagoras' theorem. And again, because that satisfies Pythagoras' theorem, if I was to make a triangle with the side 5, 12, and 13, it must contain a right angle inside that triangle. And finally, that third row, we've got 9, 30, and 41. So 41, because it's the largest number, it must be the hypotenuse. So then we're going to have, well, 9 squared plus 30 squared. Well, 9 squared is 81. and 30 squared is 900, so 900 plus 81 is 981. And then 41 squared, well, 41 squared, you can check this on your calculator, 41 squared is 1,681. And here you can see that a squared plus b squared is 981, c squared is 1,681, so no, they don't work. It doesn't satisfy Pythagoras. Because it doesn't satisfy Pythagoras, that means if I make a triangle and the sides of those triangles are 9, 30, and 41, if they're the lengths of that triangle does not contain a right angle inside it. So here in this box, and I'd love you to copy this box down underneath those three triples as examples. If a triple satisfies a squared plus b squared equals c squared, then if we make a triangle with those sides, 6, 8, 10, 5, 12, 13, the triangle that we've created, it must contain a right angle because Pythagoras works. And we know Pythagoras only works in a right angle triangle. And if Pythagoras doesn't work, there's not a right angle in there. And we saw that in that final row, that final example there. Okay, so copy that blue box down for me. And then scrolling down, I've got some questions for you. I'd like you to pause the video here and just complete this table. So copy and complete this table with a squared plus b squared equals c squared, much similar to what we did earlier there. And then there's another question after it. All right, so pause the video, complete that for me. All right, guys, thanks for completing that table up there. Hopefully you saw there was a number in those tables that satisfied, and there was a number of rows in that table that didn't satisfy, and that the ones that did satisfy, we know that those triangles, they must contain a 90-degree or a right-angled corner in them. Using that example of triples, let's move that on and let's look at that within triangles. So here's a worksheet that I'd like you guys to do, and it's Pythagoras, has it got a right angle? All right, so that's the question we're looking to answer here. Does this triangle contain a right angle? And we know that if a squared plus b squared is equal to c squared, then yes, it must contain a right angle. If it doesn't, well then no, there's no right angle in there. So let's look through this first example here. Please note that the diagrams have not been drawn accurately. Right? They're not to scale. So I look at question 1 here, and that triangle in question 1 looks like it should not contain a 90-degree corner. It might, but just looking at it, it might not. So I can't say by just looking at it. I need to test the numbers here. So going through that, we can see here that a squared plus b squared, well, it's 3 squared plus 4 squared. It's 3 and 4. We've done this earlier. 3 squared plus 4 squared is 9 plus 16. And we know that that equals 25. And c squared, the longest side there in that triangle is 5, so 5 squared, and that's 25. And we know that 25 is equal to 25, so this has got a right angle triangle in there, or a right angle in there, so it's a right angle triangle. And the right angle, it's going to be in there, opposite the largest side. Looking at example 2 there, we have a triangle that's 5, 11, and 13. Well, 5 squared plus 11 squared is 25 plus 121. And 25 plus 121 is 146. Right? C squared, which is 13 squared. 13 squared is 169. We saw that number earlier on. And here you can see quite clearly 146, it's not the same as 169. So in that case, we have 146 does not equal, so the equal sign with a cross through it means does not equal. So 146 does not equal 169. So this has not got a right angle in it. Alright, what I'd like you guys to do now, pause the video here and complete the rest of these questions, questions 3, 4, 5, and 6. Alright guys, thanks for finishing off those questions. Just quickly before we wrap up on today's lesson, let's talk about practical application of Pythagoras' theorem. Right? Many industries use Pythagoras' theorem to help check that their work is correct, and that when they want a right angle, or if something is at right angles, they use Pythagoras' theorem to do it. There's a whole range of industries: tilers, kitchen cabinet makers, engineers, builders. The list goes on and on. If you need something to join at 90 degrees and you don't have a protractor or something to help measure it, a ruler and using Pythagoras' theorem gets you out of trouble. One good example that I'm really comfortable with and familiar with is in the construction industry. They don't use the words Pythagoras' theorem on the job site. What they refer to that as is checking your 3, 4, 5s. We saw earlier in the video that 3, 4, 5, it's the most commonly known Pythagorean triple, So let's go jump onto a building site and have a look at how this would be used in a real situation. Alright, Year 9, so what we've done now, we've just jumped out and we're on a construction site, and a builder, what they might want to do here is they're looking at replacing this window, and they need to make sure the window size. So they want to make sure that this corner here is at 90 degrees to make sure that the new window that they're going to get in fits. Now they might not have a protractor on them, most builders don't, but what they do carry is their tape measure. So what we're going to do right now is we're going to check our 3, 4, 5s in that corner of the window to see if it's 90 degrees. So our first thing we're going to do is we're going to measure our 3. So we're going to get our tape measure out, place it into the corner, and we're going to measure our 3, which on this tape measure is 300 millimeters. I'm going to do that. Then up the side, I'm going to measure my 4. So I'm going to go on there, measure my 4. So I've now got my 300 measured, my 400 measured. And if this is 90 degrees, when I hold the tape measure between those 2 points, it's going to end up being 500. So if we get our tape measure and we come up into the corner here, I'll put it on one measuring point, I'll put it on the other, and you can see there right now on that tape measure, the tape measure is saying 505, which it's not 500, which means that corner isn't 90 degrees, or in builder's term, it isn't square. And to show that, math teacher, I do have my protractor with me. When I set my protractor up to measure the angle, we can see there that the angle of this corner, it's actually 91 degrees, which just proves why our 3, 4, 5 didn't work, because that angle is actually 91 degrees, it's not square, and then a builder now knows that they're going to have to manipulate the new window that they're going to put in. Alright, hopefully you guys can see it. That's a real use of Pythagoras' theorem there in real application. Alright guys, I hope you got an understanding of how Pythagoras' theorem might be used on a construction site from that example. It's just one small way that it can be used on a construction site. What I would like you to do now is the last part of this lesson, to go find something in your house, on your property. It could be a garden bed, could be a table, could be a window, something that's meant to be at right angles. And I'd like you to check your 3, 4, 5s for me, and I want you to see if you can tell if that is at 90 degrees or not. Little side note to that, please don't mark your house in a way that your parents do not, or whoever you live with does not. Please don't be putting great big dirty texture marks on windows when you shouldn't. Please make sure it's all okay. Please don't tell your parents that I said it's okay to draw on your house. Please do it in a respectful manner, but by all means, please have a go at it, and upload a photo of your measurements, and in your book, write down your results of your experiment. So yeah, I'll leave you to go on with that, and remember, correct all your work from the solutions. There are solutions at the end of this lesson note for the quick questions, as well as those Pythagoras worksheets. Upload that via a photo to Canvas, and that is all due by Friday by 3 p.m. All right, thanks very much, guys. Catch you later.